friends, once again welcome to my channel Competitive Maths by Balaji. Yes, till now we successfully completed 4 chapters, namely first one percentage and second one ratio and proportion, third one profit and loss, and fourth chapter discount. And today we are going to look new chapter called mixture. So this is fifth chapter and today we are going to look part 1 of mixture chapter. Let us see the basics concepts of mixtures and the key points in the mixture chapter. Okay, yes. Definition of mixture. A mixture is a physical combination of two or more substances. రెండు లేదా అంతకన్నా ఎక్కువ పదార్థాల కలయికను మిశ్రమం అని అంటారు. Let us take one example. Suppose we have a vessel of mixture milk and water. Suppose like milk quantity is 30 liters and water quantity is 18 liters. So 30 liters of milk quantity, 18 liters of water quantity are mixed to get the mixture. So mixture is of quantity 48 liters or volume of mixture is 48 liters. Okay, yes. We say that in which ratio milk and water are present in this mixture? Yes, that is the ratio of milk and water present in the mixture is 30 liters of milk and 18 liters of water are added together to form the mixture of 48 liters. Okay, 6 5s or 6 3s are. So milk and water ratio in the mixture is 5:3. Clearly, quantity of milk is greater than quantity of water. Quantity of milk is greater than quantity of water. So we say that the mixture is concentrated. Okay, that is mixture or solution has concentration. Let us see what is concentration. Concentration, ghadata. That is out of total quantity, the percentage of milk is known as concentration of the mixture. Yes. What is the concentration of this mixture? So concentration of the mixture is equal to, out of total are 8 units is the mixture. Out of 8 units of mixture, 5 units are milk. 5 by 8. 1 by 8 nothing but 12.5%. So 5 times of 12.5. 5 12s are 60. 5.5s are 2.5. That is 62.5%. The percentage of milk in the mixture 62.5%, that is known as concentration. Okay, and a percentage of water is equal to, total mixture is denoted as 100%. Among the 100% mixture, 62.5% is milk, so remaining 37.5% is water. Okay, yes. Now suppose we removed or we extracted 20 liters of mixture. 20 liters of mixture. So the final quantity of mixture in the vessel is, so among the 48 liters of mixture, we extracted or we removed 20 liters of mixture. So remaining mixture quantity or volume is 28 liters only. Now we have to find what is the ratio of milk to water. What is the ratio of milk to water present in extracted mixture or removed mixture? What is the ratio of milk and water in this 20 liter mixture? And what is the ratio of milk and water in the remaining mixture also? We have to find that. Okay. Yes. See here. Initially, 5 units of milk, 3 units of water are mixed together form the mixture of volume 48 liters. Now, we cannot separate the milk and water. We cannot separate the milk and water. So that the ratio of milk and water in the extracted mixture will be same as initial, that is 5:3. Why? Because we cannot separate milk and water here. So that initial ratio of milk and water is same as ratio of milk and water in the extracted mixture. And that would be same for in the remaining mixture in the vessel. Okay. So we say that the ratio of milk and water in the initial quantity, in the extracted quantity, in the remaining quantity will be same. Then what parameter is affected here? That is node point. Let us make a node point. Node point 1. When the some quantity of mixture is extracted, then the quantity of milk and water will get changed or affected, but the ratio of milk and water remains the same, in each case. Yes. When we removed some quantity of mixture from the vessel, the ratio of milk to water remains the same in each case, initial, in the extracted case, and the remaining case. But what is the parameter that would be changed here? That is, the quantity of milk and water will get affected, but the ratio will not get affected here. So let us suppose quantity of milk in the initial is 30 liters, quantity of water is 18 liters. So total mixture quantity is 48 liters. See, what is the quantity of milk in the extracted mixture? That is total 5 plus 3, 8 units. Out of 8 units, 5 units are milk into extracted quantity is 20 liters. 4 twos, 4 fives. 5 fives are 25 by 2. That is 12.5 liters of milk is extracted from the mixture. And quantity of water extracted from the mixture is, out of 8 units of mixture, 3 units are water into extracted quantity is 20 liters. So 4 2s, 4 5s, 3 5s are 15 by 2. That is 7.5 liters of water is extracted. So that total is 12.5 plus 7.5, that is 20 liters of mixture is extracted. Now let us find what is the quantity of milk in the remaining mixture in the vessel. Quantity of milk. Out of 5 plus 3, 8 units of mixture, 5 units are milk into volume of the mixture is 28. 4 2s, 4 7s. 7 5s are 35 by 2. That is half of 35 is 17.5 liters. Quantity of water in the remaining mixture in the vessel, that is out of total 8 units, 3 units are water into volume of the vessel is 28 liters now. That is 4 2s are 4 7s are 3 7s are 21 by 2. That is 10.5 liters. So total capacity of the vessel after extracted some quantity of mixture is 17.5 plus 10.5, that is 28 liters. Yes. That is what parameter is changed here? Initial quantity of milk is 30 liters. Final quantity of milk is 17.5 liters. Initial quantity of water is 18 liters. Final quantity of water is 10.5. So that is when we extracted some mixture from the vessel, there is change in quantity. There is change in quantity, but there is no change in the ratio of milk to water in the initial mixture, extracted mixture and the remaining mixture. Okay, that is very important. So తెలుగులో చూద్దాం ఒకసారి. నేను 30 లీటర్ల పాలు 18 లీటర్ల నీరు కలుపుకొని ఒక మిశ్రమాన్ని తయారు చేస్తున్నా. ఈ మిశ్రమంలో మొత్తము ఘనపరిమాణం 48 లీటర్లు. 30 ప్లస్ 18 45 లీటర్లు. ఈ మిశ్రమంలో పాలు మరియు నీటి నిష్పత్తి 5:3, అనగా 5 యూనిట్ల పాలు 3 యూనిట్ల నీరు తీసుకొని మనం మిశ్రమాన్ని తయారు చేస్తాం. మనకు తెలుసు పాల పరిమాణము నీటి పరిమాణం కన్నా ఎక్కువ ఉన్నది. దీన్ని బట్టి ఏమంటాము? మిశ్రమంని గాఢత కలిగి ఉంది అంటాం. గాఢత అనగా ఏంటిది? ఈ మొత్తం మిశ్రమంలో పాల శాతాన్నే ఈ మిశ్రమం యొక్క గాఢత అంటాం. ఈ మొత్తం మిశ్రమంలో గల పాల శాతాన్ని దాని యొక్క గాఢత అంటాం. మొత్తం 5 ప్లస్ 3 8 యూనిట్ల మిశ్రమంలో 5 యూనిట్లు పాలు తీసుకోబడింది. 1/8 అనగా 12.5%. 5 into 12.5%, 62.5%. అంటే ఈ మిశ్రమం యొక్క గాఢత 62.5%. మిగిలినది 37.5% నీళ్లు. మిశ్రమం ఎప్పుడు కూడా 100% అనుకున్నప్పుడు. నేను ఇప్పుడు ఈ మిశ్రమం నుంచి 20 లీటర్ల మిశ్రమాన్ని తొలగిస్తున్నా. తొలగించినప్పుడు తొలగించిన మిశ్రమంలో పాలు మరియు నీటి నిష్పత్తి ఎంత, మిగిలిన మిశ్రమంలో పాలు మరియు నీటిల నిష్పత్తి ఎంత? 45 లీటర్ల మిశ్రమం నుండి 20 లీటర్ల మిశ్రమం తీసివేస్తే మిగిలిన మిశ్రమం యొక్క ఘనపరిమాణం 28 లీటర్లు. కానీ నేను పాలు నీటిని వేరు చేయలేను. ఇప్పుడు చేయలేను అంటే తీసిన మిశ్రమంలో కూడా పాలు మరియు నీళ్లు అదే నిష్పత్తిలో ఉంటుంది. మిగిలిన మిశ్రమంలో కూడా పాలు మరియు నీటిల నిష్పత్తి అదే ఉంటుంది. మరి ఏం మారుతుంది ఇక్కడ? వాటి యొక్క నిష్పత్తి మారడం లేదు. ఏం మారుతుంది? వాటి పరిమాణం. ముందుగా పాల పరిమాణం 30 లీటర్లు ఉంటే తీసివేసిన తర్వాత మిగిలిన మిశ్రమంలో పాల పరిమాణం 17.5 లీటర్స్. నీటి పరిమాణం ముందు 18 లీటర్లు, తీసివేసిన తర్వాత నీటి పరిమాణం 10.5 లీటర్లు. అనగా when the sum quantity of mixture is extracted, then the quantity of milk and water will get affected. నీరు మరియు పాల పరిమాణం మారుతుంది కానీ నీరు మరియు పాల నిష్పత్తి ముందు మిశ్రమంలో కానీ తీసివేయబడిన మిశ్రమంలో కానీ మిగిలిన మిశ్రమంలో కానీ మారకుండా స్థిరంగా ఉంటుంది. ఓకే, ఇది చిన్న కాన్సెప్ట్. దీని ఇంకా నెక్స్ట్ కాన్సెప్ట్ చూద్దాం. నెక్స్ట్ ఎగ్జాంపుల్ ఆర్ నెక్స్ట్ కాన్సెప్ట్. Let us see this concept by taking one example question. How many liters of water needs to be added to 30 liters of 3:1 milk and water solution so that the mixture has milk and water in the ratio 2:3? పాలు మరియు నీరు 3:1 నిష్పత్తిలో గల మిశ్రమంలోకి ఎంత నీటిని చేర్చినచో కలిపినచో ఆ మిశ్రమంలో పాలు మరియు నీరుల నిష్పత్తి 2:3గా మారుతుంది. సొల్యూషన్. Suppose we have a mixture of 30 liters. That is initial volume of the mixture is 30 liters. In this mixture, the ratio of milk and water is 3:1. We added some amount of water. We added some quantity or some amount of water so that the ratio of milk to water will be equal to 2:3 in the final mixture. Okay. Let us suppose volume of mixture to be V2, and suppose let C1 is the concentration of the mixture, initial mixture. C2 is the concentration of the final mixture. Okay. Yes, we are added some amount of water. Now, that is, what does that mean? The ratio 3:1 has to change as 2:3. We have to change this ratio as 2:3. Now, in this type of question, always work on the parameter that is unaffected. Yes. What is the parameter that is unaffected here? We are adding water, so water is affected, and milk is unaffected. What is the meaning of milk is unaffected? That is, how much quantity of milk is there in the initial mixture, the same quantity of milk will present in the final also. What does it mean? Milk is unaffected parameter here. Why? Because we are adding only water, but we are not adding milk. So water is affected parameter, milk is unaffected parameter. What does it mean? Milk is unaffected means how much quantity of milk is present in the initial mixture, same quantity of milk will present in the final mixture. And we know that C1 is the concentration of mixture 1 and V1 is the volume of mixture 1. And final mixture concentration is C2 and its volume is V2. So that C1 into V1 will be equal to C2 into V2. So this is actual procedure, actual method. Let us suppose it is method 1. Okay. What is the concentration of the concentration? That is quantity of milk in the mixture. Yes. Why? Because milk is unaffected. We will work on unaffected quantity. Out of total 3 plus 1, 4 units of mixture, 3 units of milk into quantity of or volume of initial mixture is 30 liters. Now, what is the volume of final mixture? 30 plus we are adding some water. So this is the 30 plus W liters is the volume of final mixture. That equal total is 2 plus 3, 5 units of mixture. Out of 5 units of mixture, 2 units are milk and its volume is 30 plus W. See this? 2 2s are 2 15s are 5 15s are 75, 75 3s are 225, which is equal 2 2s are 4, 4 into 30 120 plus 4 into W 4W. 225 minus 120 equal 4W. Subtraction is 105, which is equal 4W. 105 by 4 equal what? W. That is 4 2s are 8. 2 remainder 25, 4 6 are 24, 1 remainder put 0 by taking decimal point, 4 2s are 8, 4 5s are 20, 26.25 liters of water. So we added 26.25 liters of water, so that the ratio of milk to water will change to 2:3. Okay, this is the case when we pour some amount of water, when we pour some amount of milk. Let us see shortcut method, that is a ratio method, that is called method 2. Method 2, milk to water ratio in the initial quantity and in the final quantity. In the initial, milk to water ratio is 3:1, and in the final, milk to water ratio is 2:3. Yes, but here we always work on parameter that is unaffected. Here milk is unaffected, water is affected. So the ratio of milk must be equal. We have to equate these two ratios. Why? Because milk is unaffected. Just we are adding water, but we are not adding milk. So the parameter milk is unaffected. We have to equate the ratios of milk in each initial and final mixtures. Okay. Yes. 3 2s are 6. 6 is the LCM. So to make it 6, multiply first ratio by 2, second ratio by 3. So that 2 3s are 6 is to 2 1s are 2. 3 2s are 6 is to 3 3s are 9. See, now the milk ratio in the initial mixture and final mixtures are equal. And in the initial mixture, water is 2 units. In the final mixture, water is 9 units. So there is increase in water, that is 7 units. So, and this is what initial total mixture is 8 units. 6 plus 2, 8 units. 8 units value is 30 liters. 8 units value is 30 liters. Then what is 1 unit value? 8 3s are 24, 6 remainder, put a decimal point 60, 8 7s are 56, 8 5s are 40, 3.75 liters. Then what is 7 units is equal to? 7 units is equal to 7 into 3.75 liters. That is 7 5s are 35, drop 5, 3 carry, 7 7s are 49, 49 plus 3, 52, 7 3s are 21 plus 5, 26, 26.25 liter. This is the way we have to solve these type of questions. Okay, students, let us see another concept by taking one example. Okay, example 2. 68 liters of milk was added to 3:7 milk to water solution. The ratio of milk and water in the resultant solution is 7:5. What is the volume of the original solution? పాలు మరియు నీరు 3:7 నిష్పత్తిలో గల మిశ్రమానికి 68 లీటర్ల పాలు కలపగా ఫలిత మిశ్రమంలో పాలు మరియు నీటి నిష్పత్తి 7:5 అయిన ప్రారంభంలో మిశ్రమం యొక్క ఘనపరిమాణం ఎంత? Yes, solution. So it is a volume of initial mixture. We don't know actual this value, but we know that milk to water ratio in this mixture is 3:7. Let us suppose C1 is the concentration of the mixture, initial mixture. Now we are adding 68 liters of milk. We are adding 68 liters of milk. So the resultant mixture volume be V2. Resultant mixture volume be V2. That is equal, actually suppose it is X, then it is X plus 68. Then it is X plus 68. And ratio of milk to water in the resultant mixture is 7:5. And let us suppose concentration of the final mixture be C2. Here we are adding milk in this case. So water will not get affected. The parameter which is not affected is water. Always we work on the parameter which is not affected. Since we are adding milk, water will not affected. What does it mean? The how much quantity of water present in initial mixture, the same amount of water will present in the final mixture. Okay, so that is, we know that C1 into V1 equal to C2 into V2. C1 is total is 10 units of mixture. Out of 10 units of mixture, 7 units of water. Why? Because we always work on the unaffected parameter, unaffected quantity. So water is unaffected in this case. So out of 10 units of mixture, 7 units are water. The volume of initial mixture is X. And C2 concentration is out of 7 plus 5, 12 units of resultant mixture, 5 units are water into, now volume V2 becomes X plus 68. 2 6 are 12, 2 5 are 10, 6 7 are 42x equal 5 5 are 25 into x, 25x plus 25 into 68. Consider plus 25x to LHS side. 42 minus 25, that is 17x is equal to 25 into 68. 17 ones are 17 fours are 25 fours are 100 liters. So that is initial volume is equal to 100 liters. This is actual procedure. Let us see shortcut method. That is our ratio method. Method 2. Method 2. Milk to water ratio. In the initial quantity, final quantity. In the initial mixture, ratio of milk to water is 3:7. In the final, it is 7:5. But we always work on the parameter which is not affected. Here, water is not affected. So we have to equate the terms of water in both the ratios. LCM of 7 and 5 is 35. To make it 35, multiply here by 5 and multiply the second ratio by 7. So that 5 3s are 15 is to 5 7s are 35. 7 7s are 49 is to 7 5s are 35. Yes, milk to water ratio. Now, the water is not affected in the initial and in the final mixture. But milk is increased by 34 units. Why it happens? Why? Because we are adding 68 liters of milk. That is 34 units, nothing but 68 liters. Then 1 unit is equal to 2 liters. We have to find initial volume of the mixture. Initial volume of the mixture. Initial volume is nothing but, this is initial ratio of the milk to water in the initial mixture. 15 plus 35, that is 50 units. 50 units value is 1 unit value is 2 liters. 50 units value is 50 into 2, that is 100 liters. Okay, this is our shortcut method. Next question, third one. The ratio of copper to zinc in alloy A and B are 3:4 and 5:9 respectively. A and B are taken in the ratio 2:3 and melted to form a new alloy C. What is the ratio of copper to zinc in alloy C? Yes. రెండు వేరు మిశ్రమాలు A, Bలలో కాపర్ మరియు జింక్ల నిష్పత్తి వరుసగా 3:4 మరియు 5:9. A, B మిశ్రమాలను 2:3 నిష్పత్తిలో కలపగా ఏర్పడు ఫలిత మిశ్రమం C అయిన మిశ్రమం C లో కాపర్, జింక్ల నిష్పత్తి ఎంత? Yes. We have alloy A and B. The ratio of copper to zinc is, in alloy A, the ratio of copper to zinc is 3:4 and that is 5:9 in alloy B. We have to mix these two mixtures in 2:3 ratio. in 2:3 ratio. Yes. In alloy A, we have 3 units of copper, 4 units of zinc. Total is 7 units. Total mixture is 7 units. In alloy B, we have 5 units of copper and 9 units of zinc. Total is 5 plus 9, 14 units. But question says that we have to make them in the ratio 2:3. Before that, they should be made equal. Before that, they should be made equal. LCM of 7, 14 is 14. LCM of 7, 14 is 14. To make it 14, 7 is multiplied by 2. 14 is multiplied by 1. Now see, 2 3s are 6, 2 4s are 8. 8 plus 6, 14. 9 plus 5, 14. But question says that they should made 2:3 ratio. So multiply here by 2 and here by 3. Okay? Yes. Now final ratio is equal. 2 2s are 4. 4 3s are 12. Is 4 4s are 16. 3 5s are 15. East 3 9s are 27. C4. In alloy C, the ratio of copper to zinc is 12 plus 15, 27 is 16 plus 27, that is 43. That is 43. So answer is 27 is 43. Next question. 2 vessels contains milk and water in the ratio 5:9 and 7:11. If both vessels are mixed in the ratio 4:3, find the ratio of milk and water in the new mixture. Same as usual question. రెండు వేరు మిశ్రమాలలో పాలు మరియు నీటి యొక్క నిష్పత్తి వరుసగా 5:9, 7:11. ఈ రెండు మిశ్రమాలను 4:3 నిష్పత్తిలో కలపగా ఏర్పడు ఫలిత మిశ్రమంలో పాలు నీటి నిష్పత్తి ఎంత? చూడండి, ఫస్ట్ మిశ్రమం, సెకండ్ మిశ్రమం. ఫస్ట్ మిక్చర్, second mixture. We have milk to water ratio. పాలు మరియు నీటి శాతం మొదటి మిక్చర్ లో 5:9, రెండవ మిక్చర్ లో 7:11. అనగా మొదటి మిశ్రమంలో పాలు 5 యూనిట్లు, నీరు 9 యూనిట్లు, మొత్తం 14 యూనిట్లు. రెండవ మిశ్రమంలో పాలు 7 యూనిట్లు, నీరు 11 యూనిట్లు, మొత్తం 18 యూనిట్లు. But question says that these vessels are mixed in the ratio 4:3. To make them 4:3, before that we have to make them equal. వాటిని 4:3 నిష్పత్తి చేసే ముందు ఈ రెండు నిష్పత్తులను సమానం చేద్దాం. LCM of 14, 18 is 2 into 7 into 9. 2 into 7 into 9. Yes. So here sum is 14, మొత్తం 14. 14ని 9 చే గుణించండి. ఇక్కడ 7 ప్లస్ 11 మొత్తం 18. 18ని 7 చే గుణించండి. See, 9 5s are 45, 9 9s are 81. 45 plus 81, 126. 7 7s are 49, 7 11s are 77. 49 plus 77, again 126. So their ratio will be equal, but they are mixed in the ratio 4:3. They are mixed in the ratio 4:3. Yes, 3 1s are, 3 3s are, which is equal to 4 3s are 12. 12 5s are 60 is 12 9s are 108. 7 7s are 49 is 7 11s are 77. Okay. That is, milk to water ratio in the new mixture is 60 plus 49, 109 is 185. 108 plus 77, 185. So answer is 109 is 185. Okay students, this is the part 1 of mixtures. Thank you for watching my videos. Have a nice day.